further ado, the Michael Jordan, along with Stephanie Shirkey, Paul Grimm, will be coming up to talk to us about planning for kidney transplant and living your best life possible after kidney transplant. Um, I just want to say Dr. Grimm's one of our favorite human beings outside of being a fantastic doctor.
Good morning. Thank you all for waking up and leaving the breakfast. Bacon is the best. Okay, so this presentation is to help educate the families and people living with cystinosis about sort of the life events around kidney transplantation. A lot of this information is specific to the US, but other parts of it, and the majority of it is relevant wherever you are globally. Okay, in the United States, this is the current kidney function out. And as you see in the colors, these are patients that were transplanted at different time periods. So the lowest line here is outcomes of deceased donors transplanted in 1995 to 99. The next line is 2004. Next line is 0509, 10 to 13. And the most recent pink line is 2014 to 17. So every few years, we improve graft survival. But what continues to be an issue is there's a huge difference between getting a kidney from a deceased donor and getting a kidney from a living donor. This data is always better for living donors. And if you just focus on this, when we are evaluating a person and their family who are up for a kidney transplant, we quote the average kidney from a deceased donor functions for 11.7 years. The average kidney from a living donor, 19 years. There's a huge difference, and that is not narrowing over time. So there's an intrinsically goodness to a living donor. What that also means is if you're 20 and you get a kidney transplant from a deceased donor, you're up on average for another one, 31, 44. And that's assuming that you don't wait too long for the next one. And people who are living with a kidney transplant now will probably need dialysis if they don't have another living donor. So you need to think about those issues when you're planning. Now, the doctor will tell you your serum creatinine, or you'll be able to look it up, but they often don't interpret it. So the next few slides are really understanding what a serum creatinine is and how it impacts your kidney function. So this is a screenshot of my Stanford Healthcare Labs from my iPhone, and I click on test results and a metabolic panel I had a few years ago, and it comes up like this. And if I scroll down, there's my creatinine, and it makes a guess that that's my GFR. Now, the GFR is the critical thing. Creatinine is a way to make an estimate of the GFR. Now, the GFR is normal if it's more than 90, stage 1 kidney disease, 60 to 89, stage 2. Stage 3 is 30 to 59, stage 4 is 15 to 29, stage 5, also known as end-stage kidney disease, is less than 15 for dialysis. And these different ballparks are attached to different things that you need to do clinically. Like, when do you start worrying about bone health? When do you start worrying about protein restriction or not? When do you start worrying about dealing with things like that? But creatinine is something that needs to be understood. It's made by muscle, and your blood creatinine also reflects if you had a big meat meal the night before. If you, there's a study on getting a big plate of Hungarian goulash, which is like pure meat, and then having your blood drawn the next day, your creatinine will go up by about 0.5 in American units and about 40 in SI units. Now, who would want to guess the creatinine of this fine specimen here? My guess, in American units, 2.3. Now, if I had a creatinine of 2.3, I'd be looking for a dialysis unit. Here he is when he's now an actor and he's not quite so steroid bulked, probably 1.9. And then here he was when he was our governor. It's really sad. Probably 1.3. So this very sad joke. is relevant as we're going to look at these further things. So this is a patient I looked after who was 16. He used to be very adherent to all his transplant medications. But when he was 13, mom started finding pills in his pockets doing the wash. And then he went off to summer kidney camp. And when mom was cleaning his room for the first time, it's like archaeology in a teenager's room, she found hundreds of pills under his bed. So this is a list of the serum creatinine over the 3 years before that point, and in American and SI units, but I'll graph it here. So if you look at the numbers over time, it looks like he was just gradually rising. And then there's this real spike up in the last few months. And so parents come to clinic, oh my God, what's happening? You got to fix it. He's rejecting. This is really bad. That's all of a sudden. But if you measure and plot the GFR, it's a straight line. And this actually was continuation of a problem, an issue that had been going on for years. And the problem, which we teach the medical students, is the relationship between your kidney function, which is like GFR of 100 or 125 or whatever, and your serum creatinine is not a straight line. The real relationship between your serum creatinine and your GFR is this. So you might have a normal GFR and it drops to half, and your creatinine only goes up a little bit. And for the Canadians in the room or people from South America, these are the numbers. You drop from a half to a quarter, creatinine really starts going up, and that last bit, it goes up really fast. But the GFR is straight line. So we used to use this graphic. I'm just using it to illustrate the same point. So this is the serum creatinine on the left in that same patient. And on this graph, see how long it takes to go from a 1 to a 2? Then 2 to 3, much shorter, 3 to 4, and 4 to 5 is a blink of an eye. But patients and families will say, my child was doing so well for so long, and then kidney failure just happened really fast. But when you actually look at the graphics, this had been going on for years. Now, patients lose their kidney function at a relatively constant rate, which is specific for that person. So this is one person's graphic over about a 15-year period, a gradual, consistent loss. Now, I'm going to show you a bunch of other people. Some of these have cystinosis, some of these don't. But what you can see is they all have their own rates. Here's someone who was tutoring around really nicely until they hit puberty, then it was. But just because you have a low GFR, like down here, doesn't mean you're going to develop kidney failure quite quickly, because this person had a stable GFR for years. So some people are going down fast. Some people are just hanging in there. And so plotting the GFR is important, because if you know your graph or your family's graph, you can kind of predict how long it's going to take to need dialysis or transplant. And that's relevant if you're making major life changes, like when you're thinking, when's my kid going to go to college? When my kid is going to go to the East Coast? I'm thinking of a trip next summer. We were talking about the FIFA in 2026 at breakfast this morning. So you can plan quite far ahead if your patient is like this. Now, obviously, if they stop taking their medications, the line is going to change. But in general, the line's pretty straight. But you also have to look at the patient. So this is a guy I looked after. Teenager, had his first kidney transplant at a very young age, and it was just going down over about 3 years. And when he hit a GFR of about 10, 15, we said, time to start dialysis, and he absolutely refused. And you can't hold a teenager down. But for the next year, kidney function looked stable. Had he found the fountain of youth? Had he, made a deal with the devil, right? What happened? Well, if you look at the patient, he lost 10 kilograms of muscle. He used to be a varsity athlete, and he got to the point where he couldn't even go for a walk with his mom. His grades fell from A's to D's. So the serum creatinine is only a piece of the assessment of the patient. He finally came and said, all right, Dr. Grimm, I feel like shit. My dad wants to donate a kidney. Let's go. And I said, no, you ain't getting a kidney. You're too malnourished, too deconditioned. You need some dialysis to get you in better shape. 3 months later, he comes back to me, Dr. Grimm, you are an awful doctor. I feel so much better on dialysis. Why didn't you make me go on dialysis last year? I don't have handcuffs. So you have to look at the whole patient: weight, nutrition, muscle mass, general health, and activity. So this is something I want you to put into your Google search. C-Kid U25 estimated GFR. U25 is under 25. So this is the best calculator to figure out what your GFR is, estimated GFR, if you're under 25. So this data comes from over 1,000 children with various kinds of kidney disease. 20% were African Americans, so it is a race neutral, and a significant percentage Hispanic. And so if you do that, you come across this C-Kid GFR calculator, and it looks like this. And you plug in the age, the sex, the units, so it's good for SI or American units, height, creatinine units, serum creatinine, and cystatin C. Now, we are using more and more two methods of estimating the GFR, creatinine and the cystatin C. So in this person, their estimated GFR from these numbers is 31 using the creatinine, and their estimated GFR using cystatin C is 47, and cystatin C is a blood test. And so when you have both in the same specimen, you average it out. So the best guess of this person's GFR is 39, and you can plot that over time. Now, what if the creatinine estimated GFR is great, but your cystatin C estimated GFR is poor? And that happens. And often that's because you have very little muscle and your serum creatinine underestimates the degree of kidney failure, chronic disease, amputations, severe malnutrition. So when you think about cystinosis, people do have chronic disease. They may also be very malnourished. So you may be lulled into a false sense of security by seeing pretty good creatinine. But if the patient doesn't look healthy, the cystatin C may actually reveal that the GFR is not as good as you think. If you're over the age of 25, go to the web, ask for the National Kidney Foundation estimated GFR calculator, and you can get the same data for adults. And they used to have a race data point, and that's been removed because the assumptions were not, they were raised. Okay. Moving on to transplantation. This is the outcome of people listed for a kidney transplant as children. And so they get on the list active, and by 1 year, less than half are still on the list. Most of them have had a deceased donor. Many, 20%, have had a living donor, and a few have either died or been taken off the list. And so by 3 years, most everybody is transplanted. Only 20% of the people, children that were listed, are still on the list at 3 years. If you're listed 1 day after your 18th birthday, the data is very different. You're called an adult. And so at 3 years, 40% of adults are still on the list. Only 20% have gotten a deceased donor, a few less living donor, and a lot more have died. So when you compare that side by side, it's way better to be listed in the United States as a child than. Why is that? The top 35% of the deceased donor kidneys, sequence A and sequence B, are first given to people who are 100% sensitized, so they've been waiting for years. Then a person who's already donated a kidney to someone else, and now they themselves have kidney failure, and then pediatrics. And there's a geographical issue. That's what inside circle and outside circle means. But children are highly pushed up on the list compared to people after their 18th birthday. Now, the wait list time starts either on the first day of chronic dialysis or after you've been evaluated and accepted onto the list, either active or inactive status. So your wait time is that day. Now, if you're an adult over the age of 18, the law in the US is that it's a GFR of 20 or less. But for children, there is no number cutoff. And so depending on how quickly your child is progressing to kidney disease, and depending on your program, because there are differences between programs, you can list that person inactive and start gathering waiting time so that when the child really needs to get the kidney, you might have 2 years or 3 years of waiting time, you hit the active button and they might be first in line for kidney. But the 18th birthday is the cutoff. If you get listed the day after your 18th birthday, there's no do-overs. So it's a big deal. Living donation. Around the world, but in the United States, the number of living donors has plummeted. And most of it is parents. Back when I started doing this in the 80s and 90s, 35% of kids got a living donor kidney from their parent. And that's dropped to less than 20%. But living donors from like siblings or uncles, brothers, or cousins hasn't changed. And the difference is parental health and single family households. In the United States, more than 50% of children are born into a single parent household. Donor health, which is connected to poverty, family constellation, single parenthood, and socioeconomic status, immigration status, absence of health insurance, sick and donor benefits. You can't be a living donor because if you don't go to work, you're going to lose your house or your insurance. So there's structural and systemic racism barriers to being a living donor. But it can happen. So this is patients of mine showing off recipient scar, showing off a donor scar, mom and daughter. Now, people say, well, living donation, I don't know. What if I die? Well, the chance of you dying from donating a kidney is much less than you dying from a motorcycle accident or a gunshot wound. This is America, or a car accident, and just a little more common than dying in a plane crash. So it's very rare. The health insurance people know that if you have donated a kidney, your chance of ending up on dialysis by the time you're 80 is lower than the US citizens. So people who've donated a kidney actually are great at life insurance risks because they've gone through this huge medical screen to make sure they're healthy. So having been a living donor doesn't put you at increased risk for death or kidney transplantation. But there is a difference which ethically you need to understand. You take people who've been prepared to be a living donor, but they don't donate their kidney. So they've been approved, they're ready to go, and the person they want to donate their kidney to passes away or gets a kidney from someone else. Those healthy non-donors, their chance of ending up on dialysis by the time they're 80 is this number. So the difference between people who actually donate and people who could donate but don't is 0.8%. So for every 125 adults who donate a kidney in their lifetime, one of those is going to end up on dialysis before they die when they might not have. But don't forget, if you've donated a kidney in your lifetime, you go to the very top of the kidney transplant list. So the system pays you back. And that safety net can be really reassuring, though the vast majority of people don't ever need it. Living donor, I've got some living donors, but maybe I should go deceased donor and save, save myself for, what if the deceased donor fails? It turns out living donation is a much better option for almost all children and young adults. First of all, say, I'll save myself for the next time. Your kid gets a deceased donor kidney, and then in 10 years, you've got diabetes, you can't donate. Teacher comes forward. There's a kid in my class who needs a kidney. I want to donate to him. Is it better for a totally unmatched living donor, or is it better to wait on dialysis for a really good deceased donor? The data is really clear. So this is a living donor who's from the family. This is a living donor who's a friend, a spouse. And this is a really good deceased donor. So an unmatched living donor is going to be better than a really well-matched deceased donor. So if there's any living donor, the data shows almost for every situation, living donor first is the better strategy for the long term. Now, say you're an adult, say you need a deceased donor kidney. You need to be aware that programs that look after adults, they usually see older people. Patients with cystinosis are fairly young, and many of them are very healthy. They're going to live a long time, and they're going to live to outlast that transplanted kidney. But most adults that are transplanted in adult programs are older, they've got diabetes. And so the number one cause of graft loss in adult programs is dying with your kidney still working. So the incentives for an adult kidney transplant is to just get any old kidney into a person, because that kidney is going to keep the last few years of their life wonderful. But for a young person, you need to wait for a good kidney. So you need to be aware of how we rank kidneys. So in the US and also in Europe, There's something called a kidney donor profile index, and they model the expected survival of the kidney based on a bunch of different criteria. And so when you look at the the best kidney, which is a KDPI of 0, or the worst quality kidney, which is a KDPI of 100, and you look at, say, 2-year survival, a really good kidney has an expected 2-year survival of 92%, very poor kidney, 72%. So that's a difference of 20% over 2 years. But remember, you're a young person with cystinosis, you're going to live hopefully 20 or 30 years. So let's look out 8 years. If you get a really good quality kidney, the 8-year graft survival is 72%. If you get a really poor quality kidney, it's 25%. So there's a 50% chance you're going to be back on dialysis going for another kidney if you get a poor quality kidney. So you have to balance, how good am I on dialysis? Can I wait for that better kidney? Or should I just take the next one because my life sucks? So these are the things, and you can ask. So when they give you a call, hey, we have a kidney for you. What's the KDPI? And they're going to go, oh, you've done your reading. And then they'll say the KDPI is 20%. You say, my bags are packed. They say the KDPI is 95%. You say, I'm going to a movie. I'll pass on this kidney. So those are the things that you need to know and understand. All right. I have a few more slides. Am I over time or can I keep going? All right. How do I keep my kidneys lasting longer? And this is relevant whether you have your own kidneys or you've got a transplant kidney. And there's a bunch of things. Fate. There's definitely a component of fate, obesity, activity. But there are things you can fix. So if the nurse checking your blood pressure does this, you have a serious problem and you need to take your blood pressure medicines and work with your doctor. One of the most important things that's coming out is your diet. So in America, we have this thing called the DASH diet. In Europe, the Mediterranean diet, and the Canadian diet, which is now in the Canadian Dietary Guidelines. And they're all the same from the perspective that half the plate should be brightly colored green, orange, yellow vegetables. A quarter of the plate should be protein. And notice a small amount of beef, chicken, fish, but mostly protein plant-based, legumes, beans, peas. Starch is a quarter, and rice and potatoes are not vegetables. Why bother? I mean, the donuts are. Well, it turns out there's good data. So this is a big data in the American population where they looked at the DASH score and outcomes. So in the DASH score, the higher the number, the more you're vegetarian getting your protein from plant sources. The lower the DASH score, the more you think vegetable is turkey gravy. So when you look at outcomes, so this is the average, right? For people that get most of their protein from plant sources, the risk of dying during this observation period was half the average. Whereas for people who were mostly carnivorous, the risk of dying or graft loss was twice the average during that interval. So something you can make choices about. And so if your kid's little and you're doing, your family's involved in cooking, ensuring that they get that as a habit. And if you're older and you're making your own choices, that's something to be aware of. We talk about the acid load of foods. And so this is the cumulative probability of kidney failure in people before transplant. And they have a more rapid progression to kidney failure with the highest acid load. Because acid is something that the kidney has to work to digest. And there's a lot of different biology and science. Well, what's acid? Turns out acid-producing foods are meat, poultry, and fish. So it doesn't matter if it's red meat or chicken or fish. It's just as bad from your kidney perspective. Our processed cheeses, milk sort of in the middle, whereas the good food is the alkali-producing foods, fruits, vegetables, things like that. And so when you think of a nice model for kidney happiness, it kind of looks like this. But okay, say you eat a fair amount of meat, should I just give up? This data is really fun. It shows that all you need is 3 tablespoons of vegetables a day, and your all-cause mortality is the best line. If you're down to 0 or 1 tablespoons of vegetables, that's a difference of about 20% 6-year post-kidney transplant survival. So just 3 tablespoons a day. And of course, you eat more than that, it gets better. So So all you need is a little bit to get started. Exercise. This dog is going to last a long time with his kidney transplant. His owner, not so. Last few slides. How can I keep my kidneys lasting longer? And it's the issue of urine protein leak called proteinuria. So the kidneys are like a finely tuned sports car. And when you start seeing a lot of blue stuff coming out of the tailpipe, which is protein in the urine, it's a sign that the engine's in trouble. So here's a picture of the kidneys. And as we zoom in on the kidneys, they're protected in the back, protected by bones and ribs and spine and muscle. And then you focus in on the kidney and you zoom down to the nephron level and you zoom down to the filter called the glomerulus. The filter is where the liquid leaks through, the waste products leaks through, and protein is not supposed to leak. But when it does, it's a sign of problems. Now, drugs like ACE inhibitors, lisinopril and allopurinol captopril, or ARBs like losartan, candesartan, valsartan, they all work to tell the glomerulus to relax, chill out, don't work so hard. And it takes the stress off, and there's physics behind this. It takes the stress off those capillaries and it reduces the protein leak. And when we follow the patients, when we start them on these drugs, we want to see the creatinine go up by about 10 or 20% because it's a sign that filtration has gone down and the glomeruli are taking it easy. And what you see is there's a transient. So this is that GFR graph like I was showing you, and here's the person's expected time to kidney failure, 4.6 years. There's a transient dip in the GFR, but because the glomeruli aren't being lost, they last way longer, and you may get an additional 15 years of freedom from end-stage kidney disease by regular use of these therapies. So for people with glomerular proteinuria, that's a maneuver which causes you to just push the graft loss or the loss of your native kidneys up far. And it's a bit complicated in this cystinosis. You see, children with cystinosis have tubular proteinuria, and there's no evidence that using these drugs help with infants or preschoolers or children whose urine is mostly tubular. And in fact, I've seen patients that were given lisinopril and they basically faint or they develop AKI, and the parents have sworn it off, and now they really need it when they're like 15 or 16 and they won't touch them. So when your kids are preteens and it's mostly tubular proteinuria, you don't need that therapy. But once the proteinuria changes to glomerular in the teen years, probably, then it's important. So asking your doctor if the proteinuria is mostly glomerular or tubular, and they can tell you, because there's basically a very simple test, which is cheap. And if the urine protein percent albumin, what fraction is albumin versus total protein, is more than 40%, that's glomerular, and they may benefit from this kind of therapy. Early recognition and treatment makes a difference. So being aware of the GFR and the urine protein is important. So here's a person who's fated to develop kidney failure in 7 years. You recognize that at, say, 4 years, you might get 2 or 3 more years out of it. But you recognize it sooner, you might get 2 or 3 years into this. You change the slope of that curve and you can get much more benefit. So as a person living with a kidney transplant, if you're an adult or with native kidney disease or a family member has this, so thinking about the GFR slope, thinking about the presence or absence of glomerular proteinuria can make a huge difference. And I don't know about you, but I'm going to get some barbecue at the airport. All right. Thank you very much. Actually, but just a small bit of barbecue.
Thank you, Dr. Grimm. We'll take a couple of questions. Could you talk real quick about GFR and the hydration of the kidney and how that can change?
Yeah. So when you have a person who has a fresh kidney transplant, we really push the hydration, because if the patient gets dehydrated, that could injure the kidney transplant and lead to permanent damage. And that's an issue with cystinosis patients, because many patients come to transplant with a very high urine output. And sometimes we have to have a serious talk with these people. Should we take out those kidneys at the time of the transplant or before the transplant, or maybe take out one kidney? Because you might be so dehydrated from your native kidneys that it might hurt your transplant. So that's one thing. The other thing is, when you have chronic kidney disease, the serum creatinine will fluctuate with your hydration status. Or if you're living with a stable transplant, it's the same thing. So when you're going to have your blood draw, you should make sure that you're well hydrated because then you see the best creatinine. Because if you go dehydrated and it's just a functional fluctuation, you're going to get a call from your clinic and they're going to say, come in for a redraw, drink better, maybe something bad is happening. So in general, we always tell the patients to make sure they're well hydrated before their routine labs. Chronic dehydration. Does chronic dehydration speed up kidney loss, or are we just playing with the numbers depending on how well hydrated or fully hydrated we are? No one's really sure. Like, you always hear drink 8 glasses of water, right? That's sort of like standard social media, but there's very little data behind keeping yourself well hydrated to protect your kidney if you have chronic disease or if you're post-transplant and you're an adult. So I focus primarily in those patients on making sure you're getting your medicines. That's way more important than staying well hydrated. There is some data that people who are chronically dehydrated actually have higher rates of obesity because this is an area of real interest. We're talking about this. So when you're dehydrated, the trigger into your brain that releases a hormone to make your kidneys hold on to urine also triggers cortisol release. And cortisol is an anti-stress hormone, but it also leans you toward obesity, leans you toward diabetes. And there's some evidence that people who stay well hydrated tend to have lower cortisol levels and may have less obesity. So I think it's great to stay hydrated. I prefer patients to stay hydrated, but I don't nag them about it. I'm much more focused on the meds. Does that help? I know it's very complicated.
Yeah, no, obviously it helps a lot. I was just going to mention when Jenna, our daughter, went in and we were about to get a kidney transplant.
Yes.
She was at around 25 or 26% GFR. And then while she was in waiting to get the kidney, we had the kidney on board. She was plugged in and she was getting hydrated and her kidney function went up to 38% over a day.
Like half.
Yeah. And so we called off the transplant, even though we had a donor because it had gone up that high. So we just never knew that you could. I thought when you were at 26%, you were at 26% GFR. And am I saying that right? But I mean,
and so the kid, her, sorry, she's here in the audience. We're talking about you, but
yeah,
it's okay, right?
Of course.
So chronically being dehydrated raised the creatinine, and we thought she was close to end stage. And so we had her on the list. We had her active. We got a deceased donor kidney come in. And then when we were hydrating her, just to make sure we knew everything, and her creatinine just dropped, we thought, oh my goodness, she's been chronically dehydrated. We've been thinking that her kidney function is worse than it is. We called off the transplant and changed her management to improve her hydration. And that was 2 years ago.
A year, almost
a year.
exactly.
It was like Christmas, wasn't it? Like
yeah,
a year and a bit.
Like
and
May or March.
Yeah, and so she's not. She's doing great without the transplant. And so hydration will really affect the serum creatinine number, but it doesn't change your kidney function, the real kidney function. We just have to figure out what it is. And this is a perfect example of the creatinine leading us astray.
Okay. Yeah.
You kind of answered part of my question, but what's your thoughts on someone that just had a kidney transplant and still has their native kidneys if they're like leaking protein? Because I know some people have had both their native kidneys out. Some people have had one. Some people still have, both of them in.
Mm-hmm. So we have this discussion before transplant. If you need to drink more than 3 liters a day with your native kidneys because you're making so much urine, we're worrying that the transplanted kidney may be injured because of the chronic dehydration situation. So we'll have a serious talk about maybe taking the right one out at the time of the transplant because we're so close. On the other hand, if you have been on dialysis a while, for example, and you don't make much urine anyway, then your native kidneys aren't going to hurt you that much. So, but in the cystinosis population, that's often a very good discussion to have. And I have seen some patients where they got a kidney transplant, they had chronic transplant kidney injury because they were chronically dehydrated. And like 3 or 6 months after the transplant, they had their native kidneys taken out and it stabilized them. There was some permanent damage from that first 3 months of severe dehydration. So if you don't make much urine, then we just worry about other things like severe hypertension or infection. If you make much urine, that's the discussion.
Yesterday you talked about indomethacin. When do you stop indomethacin? Is there a GFR cutoff, or and when is it safe to use indomethacin with the ACE and ARBs versus like when should you stop those?
Honestly, I don't think that indomethacin should probably ever be used with an ACE and ARB together. So I think indomethacin is in the first part of your life, infancy, childhood, preschool, maybe early school age, when you're really polyuric and your bladder's not very big and you're drinking constantly. But then as you progress into late school age and teenage years, most people are getting off their indomethacin by then. And then the ACE inhibitors and ARBs sort of in their teenage years for the average type of patient. So that's how I would look at it. Because the combination of an indomethacin plus an ACE or an ARB is very risky for the kidney because you get a bit of dehydration and that can cause an kidney injury. So we would avoid that. And I also want to emphasize for people that are on indomethacin, we always remind them about sick day rules. So if your child is on indomethacin and they get diarrhea, or they're vomiting today, or they're just dehydrated, don't give it. Because the indomethacin can aggravate the risk of dehydration causing a kidney injury. You've got a fault. Sorry.
Our daughter is exclusively, our daughter is exclusively tube fed and receives only formula. How much volume of water should be on top of, her 1,500 calories that's formula fluid intake?
It's really hard to answer. I usually look to the family. Is she thirsty? Is she, vomiting? Because dehydrated kids tend to vomit. If her serum sodium is kind of high, that could be a sign that she's not diluted with enough water. It's hard. And then it might change. Are you in an air-conditioned home where she's not sweating? Are you in an area which is really dry and really hot where she's perspiring a ton? She may need more water. I can't give you a good answer. It's sort of trial and error and your gut.
Let's take one more question, please.
For the new dual immune and kidney transplant that's being done, Jean, could you talk more where they're at with that? And is that going to affect the future if these kids can get the stem cell gene therapy as well?
So what question refers to is at our program, we're working on the combination of a stem cell transplant from a living donor as a way to be getting kidney transplant 6 months later from the same living donor and then living your life without immunosuppression. And theoretically, the transplanted kidney will not be rejected. You won't have to be on nephrotoxic immunosuppressive medications. So you don't have to worry if your teenager is not adherent. And it may be a situation where once we figure this out, could be offered to kids with various causes of kidney failure, or maybe even in places where they can't afford lifetime immunosuppression because the drugs are too expensive. So we're just very much research. But if a person has gotten a stem cell gene-corrected transplant and they're doing well with that, if they get it young enough, hopefully they'll never need what we're doing at Stanford to do a kidney transplant. Because if the stem cell transplant is done young enough, it may, like 2 years or 1 year or whatever. Hopefully, then their kidneys will last the rest of their lifetime. That's our hope. But there's no contraindication. If they do end up in kidney failure, we can talk about it. That's a long way off.
Okay. Oh, one more.
Sorry, I missed most of your talk. I really wanted to see it, but rough morning. If this question was already asked, I apologize. Is there any, from my understanding, obviously Fanconi syndrome is the proximal tube. Is there anything being done to help repair that damage? So if like someone that's young, like Henley, where her kidney functions doing really well, but she needs, but she is just wasting all of her electrolytes. And she does get the stem cell transplant and her kidney function is perfect the rest of her life. She's going to be on these medications the rest of her life, these electrolyte replacements. So I was just curious if there was any research around that.
So There is research, and first of all, if you can get the stem cell transplant early enough, hopefully the kidney will be healthy enough to be able to provide life-sustaining kidney function for their lifetime. And studies like Dr. Emma's, where they're looking at medications that might change the natural history of cystinosis early on, like repurposing things like genocide and the diet that he talked about yesterday, focus a lot on the proximal tubule, because the reason the proximal tubule is the first thing to be damaged in cystinosis is because it's so involved in processing protein that leaks through the filters. It just has this huge amount of protein that it's got to deal with. And those lysosomes get stuffed full of the broken down bits of protein. And so studies like what he's doing and other researchers can help the proximal tubule stay healthy or regenerate it. That could be huge. And so that's hopefully going to be very, very useful. The filters you have at birth are all you're ever going to have. So the filters are made in the womb, and filter production is stopped at about 34 weeks or earlier if you're born prematurely. And those filters need to last a lifetime. So if you have kidney damage and the filter is actually killed, you never make new ones. Animals below sharks can make new filters. And there's something about that level of the evolutionary tree that above that, rodents, chimpanzees, cows, no mammal can make new filters after a couple weeks from birth. So you're stuck. So that's why God gave us 2 kidneys so that we could be living donors and live a normal life, because we have tons of extra kidney tissue. You can have a normal life till you're about 10 or 15%. And so yeah.
Okay, yeah, it's always a topic that produces a lot of questions. I would encourage you to, Dr. Grimm is very accessible and is always happy to talk. So while he's eating his barbecued ribs, I would encourage you to sit down next to him and ask him a bunch